The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome and thank you for attending this morning's webinar, MAOP Reconfirmation, What You Need to Know. We're happy to have you all here with us spending your morning. Hope you had a chance to refill your coffee before Al gets us started here. My name is Marissa Davis, and I'll be facilitating. It is hard to believe we're halfway through this year. As always, we hope that regardless of where you're listening in with us this morning, that you are staying safe and healthy. We'll be taking questions at the end of the presentation today. So if you have one, go ahead and ask it via the question function, and Al will be happy to answer it for you. The host of today's webinar, G2 Integrated Solutions, provides responsive support in a comprehensive suite of asset integrity, engineering, GIS, field services, regulatory, and technology solutions that address asset performance through its life cycle. For more details on our services, please visit our website. All right, now let me introduce you to our presenter, Al Giordano. Al joined our regulatory compliance team earlier this year as a senior regulatory consultant. He's a licensed professional engineer with several years of experience in the energy industry and a focus on DOT regulatory compliance, regulatory audits, project management, and integrity management. So I will let you take it from here, Al.
All right, thank you, Marissa. Good morning, everyone. Thank you all for joining us today for this webinar. Today we're going to be going over the new MAOP reconfirmation rules, potential hiccups, and what you need to know as an operator to ensure that you're in compliance. The nexus of this rule basically is to ensure that operators will be required to focus their efforts on confirming MAOP of previously untested natural gas transmission pipelines and validating certain material and operational records related to those lines. So the first question everybody should ask is, does this impact me as an operator? Well, PHMSA's defined two sets of criteria where operators are required to reconfirm their MAOP. Criteria number one is centered on TVC records. So if you as an operator don't have TVC, so traceable, verifiable, and complete records, to support your MAOP verification under 192.619, which is your standard MAOP calculation based on your pipe design, class location, and safety factor, and your pipeline is located in either an HCA or a class 3 or 4 location, you're going to be required to reconfirm your MAOP for those specific pipeline segments. The second criteria is based off the MAOP establishment under 192.619C, which is the determination of the MAOP based on the highest actual operating pressure over a 5-year time span. So if you're using historical records to establish your MAOP, this would apply to you. So if your MAOP was determined using this criteria, you operate at a 30% SMICE or greater, and you're located in either an HCA, a class 3 or 4 location, or the newly defined moderate consequence areas. If you can run an ILI tool through those specific lines, then you're also required to reconfirm your MAOP for those specific pipeline segments. So this is just a general flow chart that kind of highlights decision points and questions to determine the applicability of the MAOP reconfirmation rule. The left-hand side of the chart is criteria 1, and the right-hand side of the chart is criteria 2. So you can see if you have MAOP TVC records for criteria 1, you're in good shape. If you didn't establish your MAOP via 619C, then the whole right side of the flow chart doesn't apply to you. So it's critical that you evaluate where you're at, what records you have, and how you came up with your MAOP to determine if this is applicable to you. All right, so the next important question to ask is, when do I have to have this done by? At a minimum, any operators who have mileage that is applicable to this requirement, you have to have your procedures in place no later than July 1st of 2021. However, if you do wish to start an MAOP reconfirmation project, you must develop and approve your procedures internally prior to MAOP project starting, regardless of the drop dead date. So if you're already looking to get some of this work done, we would highly recommend you guys get your procedures in place before you do anything else. The other key dates here, operators who perform MAOP reconfirmation, you have to have 50% of your mileage done by July 3rd, 2028, and then you have to have 100% of your mileage done by July 2nd of 2035. So you have some time to get this done. Given the ins and outs of the regulation and some of the things you'll have to do, there's some time to get it done. But the key part here is you have to get your procedures in place as soon as possible. And then for each of the deadlines, you can request an extension if necessary. Any request for an extension must go to PHMSA through their notification procedures. You have to include any up-to-date plans for completing all actions, any reasons for the extension or what the reason is for the extension, what the current status of your project is, what your proposed completion date is, any outstanding remediation activities, and any temporary measures needed to mitigate any impacts on safety. So anything you're doing to maximize the safety on the pipeline, you have to tell PHMSA what you're doing in order to have them consider any extension to this deadline. All right, so now you've figured out that you've got to do reconfirmation. Next question is, oh, how do you do it? PHMSA's provided 6 methods for MAOP reconfirmation. We're going to touch on each of these and some of the more finer points that you should be aware of. So the 6 methods listed here are directly out of code, and we'll go through each of them. All right, method 1. Method 1 is a good old-fashioned pressure test in accordance with Subpart J of Part 192. However, if you read Subpart J, you have to utilize the requirements in 192.619. You have to know what you have in the ground in order to develop a basis for your pressure test. You have to know what your pipe design is. You have to know certain material criteria and certain design aspects in order to come up with your calculated MAOP. If you choose to use this methodology to reconfirm your MAOP, you have to have material records that are considered to be traceable, verifiable, and complete. If you don't have traceable, verifiable, and complete records, then the regulation, so this is 192.624, if I hadn't mentioned it previously, 192.624 will then point you to develop procedures that are in accordance with 192.607, which is your materials verification procedures. This basically ensures that operators of any grandfathered lines or lines that they purchase where they don't have records can determine what they have in the ground to figure out what their MAOP calculations are. We'll talk about 192.607 a little bit later on in the presentation, but we'll focus on just the pressure test for right now. One of the other key points of method 1 when you're doing a pressure test is that if you have to validate your materials, this regulation requires you to test any materials that you cut out from test sites. If you're installing a header manifold or other equipment to perform a pressure test, you're required to test those materials both destructively and non-destructively in order to obtain any missing material records that you may have. So method 2 involves a pressure reduction. Operators can choose to take a pressure reduction in lieu of other options. What this does is it allows operators to avoid performing a pressure test by using this method. So basically you have to reduce your pressure and limit your MAOP to no greater than the highest actual operating pressure sustained by the pipeline during the 5 years preceding the enaction of this rule, which was 1 October 2019, divided by either 1.25 or the class location factor. So if you have a higher class location factor, you have to use the higher safety factor. The determination of your highest actual sustained pressure, it has to be the highest actual pressure for an 8-hour period. That 8-hour period does not need to be continuous. It can be made up of a variety of different time periods over the course of a 30-day time period that account for a total of 8 hours at or above a certain pressure. So this segment, or this particular method, allows an operator to basically say, hey, we're good at operating at a lower pressure. We're going to drop our pressure down in accordance with this requirement, and then we don't need to do anything else. If you changed your pipeline segment based on your class location and you don't have TVC records, TVC records being diameter, wall thickness, seam type, then you have to reduce the pipeline segment MAOP as well. One thing to note here for pressure reduction is that if you do reduce the pressure, you can uprate the pressure in accordance with subpart K, but you have to do it. You have to do it in accordance with those procedures, which would involve pressure tests and some other things. And then finally, one of the other key points here is that if you want to use method 2, but you either want to use a less conservative pressure factor, so 1.25, or the class location factor, if you want to use a less conservative factor, or you want to use a 60, a 90, 120-day span, you have to notify PHMSA, you have to provide justification for your reasoning, and you have to explain how that's going to either meet or exceed the intent of the regulation. Okay, method 3. Method 3 is an engineering critical assessment. An engineering critical assessment is basically a full technical assessment of the pipeline's MAOP. It's a procedure which determines the MAOP of the pipeline segment based on failure pressure, flaws, or defects. ECAs utilize their material properties, operating history, ILI runs, other data to determine what the predicted failure pressure of any particular flaw or defect in the pipeline is, which will then establish what your MAOP. Similar to method 1, an ECA does require a full materials verification. So if you don't have materials records, again, that are TVC, traceable, verifiable, and complete, you're going to have to complete a materials verification in conjunction with this engineering critical assessment. So the ECA does analyze and determine cracks or crack-like defects, metal loss defects, as well as analysis of interaction of defects to determine what the most limiting predicted failure pressure would be, which then allows you to develop your MAOP based on that lowest predicted failure pressure and the safety factor for the either 1.25 or the class location factor. So this is just a brief flow chart for an ECA. It starts with, at the top, starts with data gathering, pulling in your ILI runs, pressure tests, any direct assessments you've performed to figure out what the type and size of the defects that are present are, as well as your material properties. You're going to perform your threat assessment in accordance with your integrity management plan. Moving on, you're going to then determine the defects and the type and size. Once you've determined the type and size of the defects, you're going to perform your analysis suitable for that threat type. So if you've got metal loss, you're going to perform an analysis method suitable for metal loss. Once you performed your analysis method, you're going to calculate your failure pressure and your MAOP for whatever the lowest predicted failure pressure for any known or postulated defects that remain in the pipe. So if you've performed remediation on the pipe and you know you have defects that are still remaining based on whatever your IMP plan calls out, you then calculate what your failure pressure is based on what's remaining in the pipe. If you have cracks or crack-like defects, you need to calculate remaining life as well, which will then lead you into reconfirming what your MAOP is. Again, if you decide you want to use other technology for an assessment method other than what's provided, you have to notify PHMSA in accordance with 192.18. So method 4. Method 4 is the simplest, albeit probably one of the more expensive options. In essence, it allows an operator to simply replace the pipeline segment and perform requisite pressure testing and material verification associated with any new construction project. If you're already planning to replace pipe, this is probably a pretty good option to reconfirm a segment, because you're going to gather all the data as part of that pipe replacement. You're going to create new material records, you're going to perform a pressure test, so you're basically going to create all the missing records, albeit for a new section of pipe. All right, method 5. So method 5 is similar to method 2, and it involves a pressure reduction. However, this is for pipeline segments that are operating at a lower pressure, so basically a potential impact radius of less than or equal to 150 feet. This method, the differences between method 2 and method 5, method 2 utilizes a safety factor at a minimum of 1.25 or the class location factor. This method utilizes a factor of 1.1. which is reflective of the lower pressures involved as part of these particular pipeline segments. Other requirements are very similar or the same, including the determination of how you come up with your highest sustained pressure, 8 hours over a 30-day period, and the ability to uprate the pipeline segment in the future. One difference here with method 5 is there is a requirement to increase patrolling. Class 1 and 2 locations will increase from 2 times per calendar year to 4 times per calendar year. Class 3 and 4 locations will go from 4 times per calendar year to 6 times per calendar year. Any regular methods of patrolling are considered appropriate. So that's, again, it's similar to method 2, but it's changed for those lower pressure, lower stress lines. And then finally, method 6. Method 6 is PHMSA's all-encompassing alternative technology. If you have another methodology that you can use to safely determine the MAOP, you can petition PHMSA to use this method. If you do petition PHMSA, you must make sure you clearly explain what you're planning on doing, what technology you plan to use for tests, examinations, and assessments, how you plan to establish material properties, any analytical techniques you may use with analysis from utilizing prior data to ensure consistency in the results, and then as well as any other processes you use to ensure consistency with any corresponding test pressures, hydrostatic tests that you've performed on the line. Procedures and processes, again, you have to explain what procedures and processes you're using to actually conduct this work, conduct examinations, any assessments, how you're analyzing defects, flaws, and how you plan to remediate anything. You must also include any pipeline segment data, including design, maintenance, operating history, and characterization of flaws or anomalies. If you do use method 6, in accordance with PHMSA requirements, you must notify them no less than 90 days in advance of using this technology. And finally, records. Any records developed during an MAOP reconfirmation project should be retained for the life of the pipeline. Essentially, this makes sense. A lot of these lines who are going to be affected by this regulation don't have these records. So we're going to develop these records, maintain these records in the event that the pipeline gets sold, transferred to a different operator. That way that information is available. All right, so we've talked a lot about MAOP verification. Now we're going to talk a little bit about the materials verification requirements in 192.607. As I talked about previously, 192.607 is a requirement for operators to develop the procedures to verify materials for pipeline segments where they don't have TBC material records. Again, this is notable as a requirement of both Method 1 and Method 3 for MAOP verification. Once you realize that you have to go ahead and perform this type of work, you have to develop procedures to gather this data from your pipeline segments. Now, this applies to both above and below ground pipeline segments, so it's got to be applicable to both, digging and not digging. Material records specified by the rule includes diameter, wall thickness, seam type, pipe grade. For valves and flanges, you have to have a pressure rating. Additionally, this section requires any toughness values that you gather as part of this material verification process in order to either conduct an ECA or determine your predicted failure pressure. You have to retain those records for the life of the pipeline. So key points here, you have to develop the procedures. You have to show how you're going to gather this data. They should cover both destructive and non-destructive testing, direct examinations, assessments for when your pipe is exposed, particularly if it's all below grade. So 192.607, PHMSA realized that the intent to go and just dig up pipe to verify materials was going to be fairly expensive and time-consuming for operators. So the testing is not expected to be performed solely for the purpose of, or digging is not supposed to be performed solely for the purpose of material verification. but material verification should be worked into an operator's dig program to provide for testing of material verification during opportunistic times. So things like if you're doing a direct examination on an anomaly, if you're performing a repair, a remediation, you're doing maintenance, you have an excavation associated with a replacement or relocation. Operators should ensure that if they're looking for material verification, they work the verification project into any existing dig program opportunities. You should also note that as part of expected excavations, materials verification may result in the hole being open longer than expected. So this is, again, a logistical issue. You want to make sure that you have crews ready to go to perform whatever testing you need to do on a line once it's exposed, so you don't have it exposed for an extended period of time, and that everybody's working together to ensure that the data that's gathered during these excavations is gathered correctly. So you have good quality data that you can ensure that you have TPC records after the work is complete. So some other requirements in 192.607, specific to some non-destructive testing methods. If you build out a procedure, you must use methods, tools, procedures, and techniques that have been validated by a subject matter expert. So PHMSA expects that a subject matter expert is someone with formal or on-the-job technical training in the technical or operational area being analyzed, evaluated, or assessed. So the procedures, the methods, the tools, someone with formal knowledge, training, experience in that area should be validating these procedures that are going to be used. You must also conservatively account for measurement inaccuracy and uncertainty. You should manage that in the process if you know that you have tools that aren't going to, either have a margin of error, or if you have some other means that you're going to introduce inaccuracy, or you don't know if it's 100% accurate, you have to adjust for that. So slide more on the conservative side. And then finally, and this kind of goes without saying, but it bears repeating, always make sure you're using test equipment that's been properly calibrated. Keep your equipment calibration and calibration certificates, because that's going to be part of something that's going to be checked during an audit. All right, so sampling. Any operators who may have large segments of pipe that don't have material data, PHMSA has included an option to develop a sampling program. Operators can group like segments of pipe together based on certain attributes, including wall thickness, grade, manufacturing process, pipe manufacturing dates, and construction dates. When you're determining sample populations, you really need to be careful about the dates that you're using to bound these populations together. Dates between construction and manufacturing should never exceed 2 years. It's not a sliding scale. It's a hard stop after 2 years. Just as an example, so if you have pipe that's manufactured at the same time, you store it on the rack, and you install it together, say 3 years down the road, you can include that pipe in the same population segment. However, if you manufacture pipe at the same time, you take half of it, put it in the ground, and then you take the second half and you put it in the ground 2.5 years later, those are two separate populations of pipe, because they've had different environments that they've been in. So you should segregate those. Also, one of the recommendations that we have, it's not explicitly called out in the regulation, is we recommend that you keep your sample populations to the same diameter, as well as the same pipeline system. This allows for a little bit easier record keeping, delineation of specific pipeline segments, and it'll assist with the determination of MAOP. For those operators with larger pipeline segments, once you define those segments, you got to figure out how many excavations that need to happen. Basically, if you have a large population, PHMSA requires 1 per mile rounded to the nearest whole number, or up to 150 excavations if you have over 150 miles of line. So for each of the defined sample populations, when the number of excavations with the accompanying material verification needed to establish that statistical assurance, for that sample population. If you haven't exceeded that number of excavations, any other excavations on that pipeline segment is useful for sample population protocols. So you can use other excavations to help support that sampling of that pipeline segment. You should ensure that, again, it's 150 excavations over 150 miles. Usually, what we've recommended to operators that have been performing this type of work is that you should strive to have at least 3/4 of a mile between excavations. This will allow for a greater distance to determine if you have consistency with the sampling project. And that's going to be, that's a key thing, is that you're establishing consistent results. If you don't have consistent results, you have to expand your sampling program. The key here is that you have to achieve some sort of confidence level. PHMSA puts it at 95% using a standard statistical methodology. So if you're doing your digs, you're getting inconsistent results for any number of the different types of materials or the different design criteria for the pipe. If you're doing 150 excavations, you may have to go out to 200 to increase that confidence level. You may have to go to 250, but it's all based on that 95% confidence level. Anytime you do expand your sampling program, you do need to notify PHMSA that you plan on expanding it. And again, PHMSA always provides the alternative approach. If you have a better way of doing things, if you have a better methodology, you can request approval from PHMSA to use that approach. You must, again, achieve at least a 95% confidence level using that standard statistical methodology. Same notification requirements apply for this as well. You have to notify PHMSA at least 90 days prior to implementation of this type of work. All right, so finally, components. Operators, you still have to develop similar material verification procedures to establish and document ANSI ratings, with the exception of the places that are listed here in Part 1, compressor stations, meter stations, reg stations, river headers, mainline valve assemblies. You have to verify material properties for non-line pipe components. If it's greater than 2 inches in OD, if it's greater than 42, X42, 42,000 PSI, and anything that you cannot isolate, you have to go ahead and verify the material properties for those non-line pipe components. And the same thing applies. You have to make sure you have procedures in place prior to performing any material verification on non-line pipe components. So just to review real quick, I know we talked about a lot of different things. Again, first key thing is you have to determine if you have segments that are applicable to the MAOP verification requirements. TVC records, class 3 or 4, HCA. If you establish an MAOP based on operations, 30% SMICE, HCA, class 3 or 4, or an MCA. So there's those two groups. If you have segments that those are applicable to, you got to do it. Always make sure you develop your procedures first. Make sure your procedures are broad enough that it allows you to use different methodologies for different segments. You may want to do a pressure test on one segment. You may have another segment where you don't want to do a pressure test and you want to do a different methodology. So make sure you're developing your procedures that are flexible enough that allow you to change methodologies. You don't always have to use the same methodology for every segment. And then if you have to, make sure you validate your materials at those opportunistic digs. Work that into your dig program. Don't go out and dig just to verify materials, but use those opportunities where you've got the pipe exposed to gather that data that you need. So that's it for me. If there are any questions, I'd be happy to answer them as best I can.
Sure, we do have a couple here. Ready? Says, what is the definition of inconsistent material properties? Inconsistent with, inconsistent with what information?
So we're hoping that PHMSA is going to clarify this with the FAQs. Basically, inconsistent means that you're getting different material properties when you're performing your digs. You're getting maybe different ODs, different wall thicknesses. You've got different grade or seam types. Inconsistent being, and again, PHMSA is kind of loose with this language, but you're not seeing the same thing over and over and over again across the segment. And I know people have pipeline segments that have multiple pieces of pipe in it, and PHMSA's tried to adjust for this, but consistent is if you've got some records that indicate what's in the ground and you don't have anything to validate that, if you're doing your digs and you're pulling up, you're getting information on those from those digs where it's not jiving with what you already have or what you've seen in maybe a quarter mile down the road or a half mile down the road or wherever your next dig is, you may have to perform an expanded sampling. I hope that was helpful. Again, we're hoping that PHMSA is going to clarify the inconsistency part. We've had a bunch of questions about that. And if we do get more information about that, we'll be sure to make sure to let everybody know.
Okay. This says, can you speak more on the requirements that pipeline is considered to have TVC records? It says, is it sufficient to consider pipeline has TVC records if one can show pipeline size and manufacturer via, say, alignment drawings, or are more backups required, like MTR's pipeline construction test records?
So we at G2, we like to see at least a 2-document validation to make sure that something is considered to be TVC, right? If you've got one set of records that identifies a particular pipeline attribute, and then you have something completely unrelated, which can validate that. If if it's an MTR and an alignment sheet, if it's an as-built and heat records, there's a whole bunch of different combinations. We have an algorithm, we have a matrix that we use to help validate TVC records, but essentially what it comes down to is you can't rely on one record to validate what's in the ground. PHMSA's TVC definitions are very clear that one record does not substantiate what's there. So having a, as was said, having an as-built or an alignment sheet coupled with an MTR, coupled with either an as-built or heat record or weld map, that will help validate what's there.
Okay. How often do you have to perform an MAOP verification?
If you have an applicable pipeline segment where you don't have MAOP records on it, you only need to perform it once. Once you've confirmed MAOP, again, through the process, you have established, by definition, you've established the records you need to ensure that your pipeline is in compliance. So once you've reconfirmed that MAOP, you're good. And again, this is without any other clarification from PHMSA on, if there's going to be other requirements in the future. This is based on what's been promulgated so far, and then what's been discussed at conferences and other presentations. So again, if there's other information that comes out that's contradictory to what we're talking about today, we'll be sure to publish that and make sure that everyone is aware.
Okay. Are optical emissions approved by PHMSA to verify pipe grade?
Optical emissions, I would venture to say no. That's not something that's been discussed, at least that I've seen, at any presentation on pipe grade confirmation. That would probably be worth a letter to PHMSA requesting clarification on that. But to the best of my knowledge, I don't believe that's approved. I could be wrong. So I apologize if I'm speaking out of tongue here, but as far as I know, that's not an approved methodology.
Okay. It says regarding material TVC data in 192.607, did you say the toughness properties on pipe is required? Did I hear this correctly? And if so, is this mandatory?
Yes. Yes, toughness properties are required to be obtained as part of, if you're doing an ECA, if you're doing the engineering critical assessment where you have to determine your predicted failure pressure, you've got to obtain toughness properties, which would result from destructive testing, where you would have to gather materials if you're removing them from the pipe.
Okay. This says for the pressure reduction option, is the 1.25 factor the minimum? If in a class 3, is the factor 1.5?
Correct. So 1.25 would be the minimum factor. If you are in a class 3 or 4 location, that factor would modify to whatever the applicable class factor is.
Okay. Says an amendment to 0.624 was issued on July 1st, 2020, changing the scope from 192.619A to 619A2. Sorry, that's a mouthful. Can you speak about this and how it affects TVC requirements?
Can you repeat that one more time, please?
The whole thing. It says an amendment to 0.624 applicability was issued on July 1st, 2020, changing the scope from 192.619A to 619A2. Can you speak about how this affects TVC requirements?
619A to 619A2. Well, I will be brutally honest. I hadn't seen that amendment. I'm going to have to do some homework on that, and I will be happy to put out either a notice or an information notice through either our website or our LinkedIn to clarify that. But I appreciate that question. Thank you.
Yeah, or we have an email also. We can send you an email directly to you. That is all the questions that we have for today. So we'll wrap up right here. We hope you guys enjoyed the presentation. I'll be sending out a copy of the presentation as well as a link to the recording. So make sure you be on the lookout for that. And thanks for joining. We'll see you next time. Thanks, Al.